Hello everyone, welcome to today's class. Today, in the subject Maths, we are going to discuss 9th standard chapter 3 of Algebra. Chapter name is Polynomials. So in this chapter Polynomials, we are going to discuss about the operations on polynomial. So we are going to discuss the topic operations on polynomial, that is the section 3.2 of the chapter polynomial. So in this section we are going to discuss the methods of addition, subtraction and multiplication, division of polynomial. So you know to add and subtract algebraic expressions. So here two algebraic expressions are given, 5m cube minus 7m cube. So they are like algebraic terms, since m cube is the algebraic term in this, so they are like algebraic terms. So m cube is a variable in this term, so they are like algebraic terms. So we can do the subtraction here since it is m cube in both the terms. So how we will do the subtraction here? We will subtract between 5 and 7 in this algebraic terms. So the coefficient of the algebraic terms are added or subtracted while adding or subtracting the terms like this, that are the algebraic terms. So we will do it like this: 5 minus 7 into m cube. We took 5 and minus 7 inside the bracket, and m cube, since m cube is common, m cube is placed outside the bracket. So 5 minus 7, you know that 5 minus 7 is negative 2 m cube. Negative 2, 5 minus 7 minus 2 and m cube remains. So minus 2 into m cube, minus 2 m cube is the answer of 5 m cube minus 7 m cube. Next we are going with the division of the algebraic term. How we will divide this algebraic? They are unlike terms. You can see a 12a square b and 3ab square, a square b and ab square. So they are not like algebraic expressions, they are unlike algebraic expressions. So how we will do their division? So first of all we can write it in this form: 12a square b divided by 3ab square. We can write, since it is a division, we can write in this fraction form, and you can see what all are common: 12 and 3. So 12 and 3 is common, we can cancel 3 here, so 4 will be here. So the answer will be 4a square b by ab square. Now what is common in these two terms? A square and a. So a is common in both the terms, so we can cancel it. A will be cancelled and a squares, 1a will be cancelled, 1a will be remaining, and b square by b, again b squares, 1b will be cancelled, and the b numerator b will also be cancelled. So what remaining? So the remaining will be 4a divided by b. So this is the answer of 12a square b divided by 3ab square is 4a by b. Operations on polynomial. So here it is a polynomial, since here 5a square minus 2a, and we have to subtract this term from 7a square plus 5a plus 6. So these are polynomial since they contain the variable terms. So how we will subtract it? We have to subtract 7a square plus 5a plus 6 minus 5a square minus 2a. That is to subtract this term from this. So 7a square plus 5a plus 6 minus 5a square minus 2a. So first we can open this bracket by multiplying the negative sign to each of the terms inside the bracket. So it will be 7a square plus 5a plus 6 minus 5 minus into 5a square minus 5a square minus into minus 2a plus 2a. Negative into negative, it will be plus 2a. So now there is no bracket. Now how we will do the further solution? We can add and subtract the like terms. So here like terms are 7a square and 5a square. So we can add and subtract between them, but we cannot add or subtract between the unlike terms. That are, we cannot do anything between 7a square and 5a, since it is a square and a are the variables in those algebraic terms. We can only do addition and subtraction between like terms. So we can arrange the like terms, 7a square and minus 5a square. So minus 5a square, then there is no any a square term. So now we will go with the a terms, 5a and 2a. So they are the like terms in this, plus 5a plus 2a. Now what is remaining? So 5a, 2a, now only the constant term is remaining, that is 6 plus 6 is remaining. So plus 6. So now we can add subtract between the like terms. So the like terms are 7a square minus 5a square. So 7 minus 5 is 2. So 2a square will be the answer here. 2a square plus, the next is plus 5a plus 2a. So 2 positive terms. So 5a plus 2a, 7a. And one constant term, plus 6. So we can write it here, plus 6. So this is the solution of this problem. So subtracting 5a square minus 2a from 7a square plus 5a plus 6. Answer is 2a square plus 7a plus 6. So we are going with the next. We have to multiply negative 2a into 5a square. Since you can see that we cannot do addition or subtraction between unlike terms. Here there are two unlike terms, minus 2 and 5a square. So the powers of their variables are different, so they are unlike terms, but we can do multiplication and division between unlike terms. So we can multiply both these terms. So the answer will be minus 2. We can first multiply the numbers, then variables. So minus 2a into 5, it will be negative 10. Negative 2 into 5 is negative 10. Then we can do with the variables, a into a square, it will be a cube into a cube. Minus 10 into a cube is minus 10a cube. So this is the answer. So this is the next problem, 5m square minus 2a into 5m cube plus 2m minus 2. So we have to multiply two polynomials. How we will do it? So here two terms are there inside the bracket, so we will have to multiply each term of the second polynomial. This is the first polynomial and this one is the m cube plus 2m minus 2 is the second polynomial. So while opening the bracket, we will have to multiply each terms of this in first polynomial with the second polynomial. That is, all the terms of this polynomial must be multiplied with all the terms of this polynomial. So how we will do that? First we will multiply with m square all the terms of the second polynomial, then we will multiply with minus 5 all the terms of the second polynomial. Means we will minus 5 into m cube plus minus 5 into 2m minus 5 into minus 2. So we will do that. So first we will multiply all these terms on the second polynomial with the m square. So equal to m square into m cube plus 2m minus 2. Now the second polynomial here, minus 5, we will multiply all the terms in the second polynomial with the minus 5. Minus 5 into m cube plus 2m minus 2. Now we will open the bracket. As usual, you know, we have to multiply m square with all the terms. That is, we will open the bracket. So m square into m cube, m raised to 5 plus m square into 2m, it will be 2m cube, m square into minus 2 2m square, minus 5 into m cube, minus 5m cube, plus minus 5 into 2m, it will be minus 10m, and minus 5 into minus 2, it will be plus 10. Negative into negative, it will be positive, so positive 10. Now we have to arrange between like terms. All the like terms will be together, so that we can do the solution. So m cube is the first term, so there is no any other m cube, m raised to 5 is the first term, so there is no any other m raised to 5 term, so we are going with the next term, 2m cube. So another m cube term is this one, minus 5m cube, so we will write it minus 5m cube. There is no any other m cube term, so we will go with the next, and that is m square, minus 2m square, and there is no any another m square term, so we will go with the m terms, that is minus 10m. You can see that we since we have already written this term minus 5m cube here, so we don't have to write it here, we can go with the next term. So we are going in the order of all these algebraic terms. First we write the m raised to, we will go in the descending order of the powers of the m, that is first we will write m raised to 5, then m raised to 4 is not there, so m raised to 3, then we will write all the terms of m raised to 2, then we will write all the terms of m raised to 1, that is m, then last we will write the constant term, that is plus 10. So now we can do the solution. m raised to 5 is only the one term, so we will just write it m raised to 5 as it is, plus 2m cube minus 5m cube. 2m cube minus 5m cube is minus 3m cube, minus 2m square, it is the only term, so we will write just as it is, minus 2m square, and minus 10m, so it is also the single term, so we can't do any further solution to that, and plus 10, that is also a single term, constant term. So this is the solution of this multiplication. So this is solution, m raised to 5 minus 3m cube minus 2m minus 10m plus 10. So here the degree of the product is m raised to 5. M raised to 5 is the degree of the product. Highest power is m raised to 5. Now we are going with another problem. We have to add these two polynomial, 3m square n plus 5mn square minus 7mn plus 2m square n minus 2mn square plus mn. So we have to add these two terms, mn plus 2m square n minus 5mn square plus mn. So we have to add the two term polynomials, so we will arrange, we doesn't need to open any bracket since it is addition, so we can do it directly. So we will arrange the like terms together. So m square n is the first term, so other m square n term is here also, you can see m square n term is here also, so we will write it 3m square n minus it is mn square, we need m square n, so the m square n term is here, 2m square n, so we will write that 2m square n, 3mn square plus 2m square n. So we will go with the next term, that is plus 5mn square plus 5mn square. So the mn square term is minus 5mn square, so we will write that minus mn square. So 5mn square minus mn square, so the next term is mn term, that is minus 7mn, minus 7mn, and the like term to mn is plus mn, here also you can see mn, so we will write it here, plus mn. So all the terms are covered, have written in this second step. So now we will go to the next step. So in this we can add all the like terms or subtract all the like algebraic terms. 3m square n plus 2m square n, it is 5m square n. 5m square n plus, we'll go with the next, 5mn square minus mn square, so it will be 4mn square plus 4mn square. So we can see the difference, it is m square n and it is mn square. It is a square is on m and here square is on n, and the next term is minus 7mn plus mn, it will be minus 6mn, minus 6mn, that is minus 7mn plus mn is minus 6mn. So we did with this and this. So we got the solution it is 5m square n plus 4mn square minus 6mn. So we are going next with the division of two polynomial. We have to divide 2 plus 2x square divided by x plus 2 and write the answer in this form. Dividend is equal to divisor into quotient plus remainder. This is the usual division form. So we have to divide this polynomial, two polynomials, and write in the division form. So we have to divide this polynomial. This is a higher polynomial with this one. That is, we have to divide 2 plus 2x square divided by x plus 2. So first let us write the first polynomial which we need to divide in the standard form. So p of x is equal to 2 plus 2x square is the polynomial which we need to divide. So we will write now it is not in the standard form. Standard form means the higher degree of the algebraic terms, higher degree to lower degree we will write the polynomial. So now it is not in the standard form, so we can write it in the standard form. So standard form we will write the higher degree first, 2x square. So x square we write first, the next term will be of that of x. So here x term, you cannot see x term in this two polynomial. The x term is not here, so we will write it as 0x. That means 0 into x is 0. So here x term is not there, so we will write it as 0x, and constant next will be the constant term. So 2 is the constant term here. So we write the polynomial as 2x square plus 0x plus 2. So this is the standard form of this polynomial. So now we can divide the two polynomial, that is 2x square plus 0 into x plus 2. With what we divide? We divide it with x plus 2. Can see x plus 2. So we have to divide this polynomial. So we write this polynomial in the standard form. We are going to divide it with x plus 2, the second polynomial. So for starting the division, we will look at the first term. So here the highest degree power first term is 2x square, and here it is x. So when we divide 2x square by x, that is 2x square by x, x will be cancelled, 2x is remaining. So 2x will be written in the quotient place, we will write 2x. Now we will multiply with this quotient 2x all the terms on the divisor, all the divisor terms we will multiply with the 2x. So it will be 2x into x is 2x square, next 2x into 2 is plus 4x. So now we will subtract between this and this. So for subtracting, when we subtract, we have to multiply the negative sign with all the terms on the second step. So minus 2x square and minus 4x. So now we will do the subtraction. 2x square minus 2x square, it will be 0. and 0x, that is 0x means 0, 0 minus 4x is minus 4x, and what remains here? Plus 2 remains, so we will write it down as it is, plus 2. Now again we will divide the first term of the polynomial minus 4x with the x, that is the first polynomial on the divisor. So minus 4x divided by x, that is first polynomial of the dividend divided by first polynomial on the divisor. 4x minus x, so here x and x is common, x get cancelled, minus 4, so minus 4. So minus 4 we get as quotient. Now we will divide this quotient minus 4 with all the terms on the divisor. So we will multiply minus 4 into x is minus 4x, and minus 4 into plus 2 is minus 8. So now we have to subtract the two terms here. So to subtract, we will have to multiply all the terms on the second step with negative sign. So negative, here already negative is there, so negative into negative it will be positive, and here also negative into negative it will be positive. Now we can do the direct subtraction, minus 4x plus 4x, so it will be 0. Two like terms get cancelled, minus 4x plus 4x it will be 0, so it will be 0, plus 2 plus 8, that is 2 plus 8, that is 10. So 10 we got 10 as remainder, so we doesn't need to do the further division as we got 10 as the constant term as the remainder, so the division ends here. So now we already returned the dividend. Dividend means the term which we divided, 2 plus x square, as p of x is equal to 2x square plus 0x plus 2, or 2x, p of x is equal to 2 plus 2x square. Now we can write the divisor term as let q of x be the divisor. Divisor means the term with which we divide here. So which term we divide here? With x plus 2 we divided this polynomial, so q of x is the divisor here, so q of x is equal to x plus 2. Now the quotient term, so quotient means the answer we got here, so here quotient is 2x minus 4, so let s of x be represent the quotient here, so quotient is equal to 2x minus 4. Now we will go with the remainder. Remainder means the term remain, the constant term we get after the division. What remains after the division is we get positive 10 as a remainder, so we will write it as r of x. Remainder be represented as r of x, so remainder is equal to 10. So now we can write the question was write the answer in this form, dividend is equal to divisor into quotient plus remainder. So here dividend is p of x, so we can write it here. Before that, you see that when we divided this polynomial with the x plus 2, that is our question was 2 plus x square divided with x plus 2, we get the answer as 2x minus 2 and the remainder as 10. So now we can write it as the dividend is equal to, that is 2x square plus 2 is equal 2 plus 2x square, we can write it as in the question, 2 plus 2x square, that is dividend. When we divide it, we will get as, when x plus 2 divisor x plus 2 is multiplied with 2x minus 4 and add 10 to that term, that is we multiply x plus 2 with the 2x minus 4 and add 10 to that the answer with the product of the x plus 2 and 2x minus 4, we get an answer, a product, and add 10 to that product, we will get 2 plus 2x square. So this is how we write this division. So now we can write, we have taken 2 plus 2x square as p of x, so we will write p of x is equal to x plus 2 as q of x, that is the divisor, q of x into 2x minus 4, that is s of x. X of x is a quotient here, so we will write s of x plus 10. 10 is the remainder here, that is r of x. So r of x. So we have represented this problem using this in this form, that is dividend is equal to divisor into quotient plus remainder. Hence solve the problem. Going with the next problem, it is a word problem in the section 3.2. Problem 1, third question. For the parade, there are y students in each row. Row means, you know, row is when there are y students, that means 1, 2, 3, 4, the third student up to y terms. In a parade, there are y students in a row, that means up to the y there are students. So this is the first student, second student, third student, fourth student, and up to y students means we doesn't know what number is y. So y students stand in a row, and what is next given in the problem, and x such rows are formed. So this is the first row, and like this rows, x rows are there, x number of rows are there. So we will write it as the first row, second row, third row, and in this way x rows are there. So we have to find then how many students are there for the parade in all. So we have to find the number of students in this parade. So you can see that there are y students in the first row. So the second row, third row will also have y number of students, that is second row will have the second student, third student, 4 up to y students will be there, and here also y students in the third row also, and in the xth row also there will be y students. So we have to find the total number of students standing in all the rows, total number of students standing in all the rows and columns. That means all the students who are standing in this parade, we have to find the total number. So before to understand this problem, so let us assume there are 4 students in a row, 4 students in a row. So 1, 2, 3, 4 students in a row, and likewise 3 rows are there, that is first row, the second row, third row. So 3 rows are there and 4 students in each row. So how we will find the number of students in each row, in the period, in this parade, how many students will be there? We will find it by 4 into 3, that is 4 students in each row, and like that way 3 rows are there. So how many total number of students, we will find it by 4 into 3, multiplying 4 into 3. 4 into 3, you know, 4 into 3 is 12. So we can 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 students are in this row, where 4 students are in each row and 3 such rows are there. So how we find it? We multiplied number of rows into the number of students in each row, that is 4 into 3, we get the total number of students. So here y number of students are in the row and x such rows are there. So how we will find the answer here? X into y. X into y is xy. So xy students will be here in this parade, that is xy students are there in this parade. So we can write it in the answer form. So the first step is number of students in each row, given as y. So number of students in each row is equal to y. Next it is given that x such rows are the number of students in each row. The next step will be number of rows in the parade. The number of rows in the parade is given as y such rows are formed. So x such rows are formed. So x number of rows in the parade is equal to x, and number of students in each row is equal to y. So you can see it is given y and x. So now the third step is total number of students in the parade. So the total number of students in the parade is equal to x into y, that is xy students will be there. We doesn't know the number of x and y, so we write it as in the algebraic terms, that is xy students will be there in the parade. So answer is xy. So hence the problem solved.